Welcome back on the lesson on limits, and this time we'll take a look at a new group of limits where we practice how to find the limit of a function by using a method that we call the conjugation method. So when do we use it? We use it in rational functions that contain radicals. We're going to take a look at our first example, example B4. We have the limit as x approaches 9, root of x plus 7 minus 4 over x minus 9. And if we substitute x by 9 as this limit suggests we do here, we get 9 plus 7, 16. Square root of 16, 4. Minus 4, 0. So the numerator is 0. Now x equals 9. That means the denominator becomes 9 minus 9, also 0, which means that this is an indeterminate form limit. So we have to simplify it so that we're able to determine it. But we just discovered that at x equals 9, both numerator and denominator become 0, which means that x minus 9 is a factor of the numerator. And obviously, it's a factor in the denominator because it's the only expression we see that. So it's a factor of the numerator. So the problem now is that I understand that x minus 9 can be a factor, but how do I get x minus 9 factored from a radical? Because x is hiding inside the square root, so inside the radical, we cannot actually factor right away. We need to first get x outside the square root symbol or square root sign or outside the radical. And what we do in this case is we use the difference of squares formula and we multiply the numerator and the denominator by the conjugate of the numerator. In other words, we say we rationalize the numerator. Remember that the conjugate will be exactly the same as the expression we see in the numerator. Let me move this a little bit. Okay, but the only difference will be that the sign between the terms will have to be positive. So you see this is a negative, so we have to change it to positive. Now everything else stays the same. So the root of x plus 7 stays the same, and then plus 4. So a common mistake people make is because they remember they have to switch the sign, they switch the signs everywhere. Please don't make this mistake. The only sign we're changing is the sign between the two terms, so one of which is a radical or is in radical form. So because we're multiplying the numerator by something new, that means that we're changing the value of it. So to fix what we just did here, we are multiplying the denominator by the exact same thing. So that means we're multiplying the entire function by 1, right? Because something divided by itself is equal to 1. So next we will simplify. So we have x approaching 9. I'm going to draw a long, long line. Here we go. And I'm going to show the steps in here, but obviously with practice you will learn which steps are more common sense and can be done a little bit faster. So based on the difference of squares, so we have created the difference of squares, formula here. So that would be a squared minus b squared, right? And down in the denominator, we'll have x minus 9 multiplying the root of x plus 7 plus 4, which obviously has to stay inside brackets because it's in binomial form. And another thing is that x minus 9 has to be inside brackets because look at what happens if we don't. So it seems as if only 9 is multiplying the binomial. But as a matter of fact, the entire denominator that we had, x minus 9, is multiplying the conjugate, which is root of x plus 7 plus 4. Now, another common mistake that we make when we are evaluating these limits, most typically people like to start expanding and simplifying, and it makes sense to expand and simplify the numerator. Why? Because we can't wait to get rid of this radical, right? So we are going to do that, and that will give us, remember, the power of 2 and the square root cancel each other out if you want to put it in these words. The idea is that we're going to get x plus 7 here, and then minus 16. And in the denominator, we have x minus 9, and then again the root of x plus 7, and then plus 4. Now remember that it is very important that we do not expand x minus 9. And I like to jokingly say that we want x minus 9 alive because we cannot wait to simplify x minus 9. And if we expand it, x minus 9 will merge with the other terms and we won't be able to see it as a factor so that we can eliminate it. So again, if this is something that, you think is worthy of, noting it down and remembering, please write it down somewhere on the side of your paper and avoid making this mistake. So x approaches 9. Now, as you can see here in the numerator, we obtained 7 minus 16, negative 9. So exactly what we wanted. And here we go. And you got to keep on writing this conjugate here, which is kind of tedious, I admit, but we have no other choice but write it. And now is the fun part. We will chop, and the limit now is in a more simplified form. So x approaches 9, and then we have 1, and then we have root of x plus 7, and then plus 4. Now, let's take a look and see what's going to happen when we substitute x by 9. Obviously, there is nothing else to do but make x equal to 9. And look at this. So we have 1 root of 16 plus 4. So that would be 1 over 4 plus 4, or 1 over 8. So the limit of this function will be 1 over 8.